This video is for the first workshop we're having on quadratic functions. In this workshop, we're going to cover the standard form of a quadratic equation, how the coefficients of the equation affect the graph, and how we can tell the solutions when looking at the graph. First, let's review the standard form for a quadratic equation. Hopefully you remember this from doing the web quest. It's ax squared plus bx plus c. A couple of things to note here. First of all, a cannot be 0. Second of all, a, b, and c are just numbers. In order to apply this to an example problem, we just have to look at the problem and compare the numbers that are in the positions of a, b, and c respectively. Now, we know that a is the number in front of x squared because our formula starts with ax squared. So in this problem, since it says 4x squared, a is going to equal 4. Next, we know that b is the number in front of the x because in our formula it's bx. So in this problem, b equals 7. Finally, c is the number that's all by itself, usually at the end of the equation. So in this problem, c equals 3. We'll follow the same steps in example 2. First, for a, we'll choose the number in front of the x squared, so a equals 2. b is the number in front of the x in our equation. So in this case, b equals -5. Remember, the minus sign goes with the number after it, so that's really going to be a -5 and not a +5. Finally, c is the constant, the number by itself, so c equals 9. Continuing on with example 3, we'll follow the same steps. Notice that there is no number in front of x squared. So a has to equal 1 because it's the only number that can be invisible in front of an x. b equals 8 and c equals -4. We'll continue this same process in examples 4 through 6. One thing you might notice that's different in 4 through 6, however, is that we only have 2 terms in each problem. One of our terms is missing. In this case, that means the coefficient of that term must be 0. So whichever part of our equation is missing, that letter is going to be 0 in our answer. In example 4, for example, there is no constant term. There's no plane number, so c has got to equal 0. A is 1 because the 1 is visible in front of the x squared, and b is -10. In 5, the term we're missing is actually the middle term, the x term, so a equals 1, b equals 0, and c equals -9. Finally, in 6, we are once again missing our constant term, our plane number, so a equals 1, b equals -3, and c equals 0. As you can see, this process is not exactly hard, but we're going to be using these coefficients a lot in the coming days, so it's really important that we spend this time to practice identifying them properly. Next, we'll review what you should have learned from doing your calculator lab yesterday. When c is positive, so in other words, when we add a positive number to the end of our equation, that moves our graph up. You can see an example of that here with the comparison of x squared in gray and x squared plus 3 in black. Notice that the black graph is moved up from the gray graph, so this shows us that when c is positive, the graph shifts up. When c is negative, it makes sense that the reverse should happen. So if c is negative, it shifts the graph down on our axis. So in our example here, we see x squared in gray again, and x squared minus 3 this time is 3 units lower on the graph than the x squared parabola. The a, the very first number in our equation, controls which direction the parabola opens. When a is positive, the parabola opens up. That means the lines are going up on this kind of parabola. On the other hand, if a is negative, then the parabola opens down, as in this example, y equals -x squared. Our a here is -1, so our parabola has to flip upside down and open in the down direction. The a also controls how wide the parabola is. If a is bigger than 1, then the graph gets narrower. This also works if a is less than -1. The graph also gets narrower. In that case, it's just flipped upside down. So we say this by saying that the absolute value of a is greater than 1, then the graph is narrower. If the absolute value of a is less than 1, meaning if a is a fraction because it's between 0 and 1, then the graph gets wider instead. Now, this kind of seems backwards on first thought because we think of wider as being bigger. But what the a is really controlling is how steep the line is. So the bigger the a, the steeper the line of the parabola is. So what that means is the bigger the a, the skinnier it gets because that line is getting steeper and steeper and going up faster and faster. When a is smaller, like a fraction, that means the parabola is not going up as quickly, and so it gets wider because it's a less steep curve. The final thing we need to talk about in this workshop is solutions of quadratic equations, and specifically how to find them on a graph. First, though, I need to warn you that we use 3 words with the same meaning in this section. Solutions, roots, and zeros all mean the same thing in this context, and I will use those 3 words interchangeably. So anytime I use one of them, I mean the same thing as if I use the other 2. Finding solutions on a graph is actually really easy because the solutions are at the x-intercepts of the graph. In other words, where the graph crosses the x-axis. Let's take a look at the first graph to figure out what exactly this means. We just said the solutions are going to be at the x-intercepts, where our graph crosses the x-axis. So first we need to remember that the x-axis is going horizontally across the page, side to side. Once we remember that, we can easily see that here is the first solution of this parabola, where that arrow is pointing to where it crosses the x-axis. This parabola also has a second solution at the other place where it crosses the x-axis, right here. In order to figure out the actual solutions, or roots, of this parabola, we need to figure out where this graph crosses the x-axis. The first place the graph crosses is 1 unit over, because it's one little tiny marker line over. So our first solution, our first root, is at x equals 1. If we continue counting over to find the second solution, we can see that our second solution happens at x equals 3. Also, we can notice that we have a total of 2 solutions in this parabola. As you look at the second parabola, hopefully you are identifying the 2 solutions that this parabola has. One on the left side of the graph and one on the right side of the graph, the 2 places where it crosses the x-axis. In order to figure out exactly where these solutions or zeros occur, we just need to count how many units they are from the origin. The first one is 3 units to the left, so that solution is at x equals -3. The other solution is 3 units to the right, so that 0 happens at x equals 3. And this one, again, has 2 solutions. The next parabola opens upside down. Remember that this means that a has to be negative. This one has 2 solutions, where the 2 places where it crosses the x-axis, at -4 and 4. Our fourth graph is a little bit different because the graph just barely touches the x-axis in one place, so this graph only has 1 solution. That solution happens at the vertex, or the minimum of that parabola, and it's 2 units from the origin, so it's at x equals 2. Same thing happens with the next parabola. Again, it just barely touches the x-axis, the vertex lies on the axis at -2. So this one has 1 solution at x equals -2. The final parabola does not touch the x-axis at all, so this one has no solution, has 0 solutions. One final thing that I'd like to point out about the number of solutions of a parabola. Quadratic equations can have 0 solutions, they can have 1 solution, or they can have 2 solutions. So you have to be careful when you solve quadratic equations to consider how many solutions it might have.